Hello students, today we are going to discuss a very important topic, that is stability of resonating structure. How to determine the stability of resonating structures of particular compound. So let's discuss. So for determining the stability we have following 4 points, and these 4 points always we have to analyze in resonating structures to determine their stability. First point is compound resonating structure having non-polar resonating structure are more stable than the polar resonating structure polar resonating structure. Now we have second point, higher number of pi bonds. Resonating structure which have a higher number of pi bonds, resonating structure having higher number of pi bonds are more stable. Now third point, we have negative charge on electronegative atom is present, and positive charge on electropositive atom is present, then the compound should be stable. Now we have fourth point, distance between the like charges, that is positive charge and negative charge is more, then stability will be more, and if distance between the negative positive and positive negative charge means unlike charges is more, then stability will be less. Now let's take example. So take example of this compound. We have two resonating structures, a lone pair. This lone pair jump migrates here, and we have three triple bond here, double bond. Now let's analyze. So we will analyze the stability order in the similar sequence. So first of all, we will see whether the compound is polar or non-polar. Now we see that both these compounds are polar compound. So first is not applied here. Now second, more number of pi bonds. So we see that in the second resonating structure, here three bonds are present, and here means here two pi bonds and one sigma bond, and here only one pi bond is present. So in this case, second resonating structure will be more stable than the first resonating structure. Now no need to apply another this third and fourth rule. Third, no need to apply. Here we got second, that is one structure have more number of pi bonds than the another structure. Now let's take the example of another compound. Here we have CS3 as positive, CS3 O negative, and this negative charge jumps here, and we have CS3 as CS3 double bond O. Now this is first resonating structure and this is second resonating structure. Now we have to determine the stability, then apply the rule as firstly check whether the compound any resonating structure is non-polar or not. Then we see that the second resonating structure is non-polar. In this way we see that non-polar is more stable than the polar. This is polar and this is non-polar, so this is more stable. So we know that non-polar is more stable than the polar. Polar means here charge is present, so polarity develops here. Here if positive or negative or both charge is present, then the polarity develops here. In this way this compound is polar, and this resonating structure is polar, and this resonating structure is non-polar. So non-polar resonating structure are more stable than the polar resonating structure. So this second resonating structure will be stable than the first resonating structure. In this way we will determine the resonating structure's stability. Thank you very much.